All right, so we're talking more about linear equations today, and today we're talking about something called point-slope form. But before we do that, I just want to remind you, so far we've learned about slope-intercept form, and what we know is that m is the slope, b is the y-intercept, and x and y here in the equations are a point that are on the line. All right, so let's talk about point-slope form, which looks a little bit different, and it comes from the slope formula. So I'm going to start by writing out our slope formula. That is y2, let me go back, sorry. That is m equals y2 minus y1 over x2 minus x1. If I were to solve this to make it not a fraction, I could multiply both sides by x2 minus x1. And that would cancel out the fraction part and leave me with an equation that says m x2 minus x1 equals y2 minus y1. Or another way to write that, and this is what point-slope formula looks like, is what we normally see as y minus y1 equals m parentheses x minus x1. So as you're used to, m here is going to stand for the slope, and y1 and y2 are going to stand for a point on the line. That is very important to note, all of those things really. And what I also want to help you understand is that these negative signs that are on here are going to indicate that we're going to use opposites. So keep that in mind. All right, so let's look at some examples. So if we're interpreting something in point-slope form, here's two examples for us to look at. In this first example, I have y minus 8 equals 2x plus 7. The easiest thing to identify is the slope here in the front. So this slope is going to be sitting in front of the x, which would mean that the slope of this problem is 2. Now remember, these other points give me the x and the y coordinates. And what I just said was that they're going to be opposites. So this is my x1, and here is my y1. So make sure that when we name our ordered pair, the x goes to the x spot, the y is going to go to the y spot. So my ordered pair is going to be the opposite of that x, so negative 7, and the opposite of that y, so positive 8. All right, take a second to pause the video and see if you can figure out the slope and the point for this other equation. All right, the slope again is sitting in front of this set of parentheses, so my slope here is going to be negative 1. And again, x and y, but I'm going to use opposites, so my coordinate is going to be negative 4, negative 3. All right, now we can use that to actually graph things, on a graph. So what we can do with that, if you will practice this one, I've been given this equation, and I know here that my slope is going to be negative 4, and the ordered pair that this gives me, x and y, is going to be the opposite, so positive 8 and negative 1. So to graph this, we can start using that point, so positive 8 and negative 1. Make sure that you're doing good graphs for yourself. And then I can count a slope of negative 4 here from this point. So I don't have to go necessarily on the y-intercept with these. I can start at any given point. So I'm going to go down 4 and to the right 1, right? Negative 4 over 1. Or I can do the opposite, go up 4 and left 1. And that will give me some points to make a linear equation. Hopefully yours is connected better than mine. All right, and as I promised you in class today, we're going to talk about writing equations using point-slope form. So this is actually what I think is a better method for writing equations. Notice in this example, they give me 2 points. So I'm going to start in the same place that I did before. I still need a slope. So I'm going to do y2 minus y1 over x2 minus x1. All right, that's going to give me 1 minus 3 over 2 minus negative 1. Negative 2 over 3, so remember that minus negative is going to change to a plus here. So my slope is going to be negative 2/3, that's my slope. And now we have a choice. We need a point. And notice in this instance, just like with the ones we did yesterday, we have 2 points to choose from. If you remember, I'm going to choose the one that has the least amount of negatives, if I can help it, and has smaller numbers, which in this case is going to be 2, 1. So I'm going to set up my equation. This is y minus, so remember, the formula says y minus y1 equals m times x minus x1. So I'm going to do y, and then I need to do an opposite. So the opposite of 1 here will be negative 1 equals m negative 2/3 x minus, and then I need to do the opposite of the x value, which is 2, so x minus 2. If the problem says to leave it in point slope form, then I can stop there, and that's all I have to do. You could do this problem similarly by using the other point. So if we use negative 1, 3, this would look like y minus 3, so I'm going to use the y value, equals negative 2/3 x. And now it's the opposite. So since that says negative 1, I'm going to write plus 1. All right, that is an equivalent equation. If we simplified, both of those would end up being the same thing. So I'm actually going to walk you through the simplification process just to show you what I mean by that. So these are in point slope form. And I'm going to show you how we change these into slope-intercept form. So to change them into slope-intercept form, we're going to, we want them to look like y equals mx plus b. So now we're going to change into slope-intercept. So first I'm going to distribute. That's going to give me y minus 1 equals negative 2/3 x. When we multiply fractions, remember we multiply the tops. This is going to be plus 4 over 3. And then all I have left to do is to change where this 1 is and move it over. So I'm going to add 1. That will give me an equation of y equals negative 2/3 x. 4/3 plus 1, this is a quick reminder, you need to have common denominators to add. So I can rewrite 1 as 3 over 3. So if I do 4/3 plus 3/3, that's going to give me 7/3. So this equation will be negative 2/3 x over 7 plus 7/3, sorry. All right, in class tomorrow, we will work this other one just to show that it will actually give the exact same equation in the end.